Assalamu alaikum, dear students. Welcome to the platform of Quanta Publishers. This is lecture series Teach Yourself, and today we are going to start a new course about electromagnetic theory. Here is the chapter number 1. You will see this chapter belongs to vector calculus and the Dirac delta function. Let us move on. Here is the list of topics we will cover in this chapter. And the first topic in this chapter is about the introduction to vector algebra and calculus. Let us start with the basic concept about the physical quantities. You see, the quantities which can be observed, described, and measured are known as the physical quantities. Physical quantities can be divided into two parts. The first one is the scalar quantity, and the other one are the vector quantities. The scalar quantities can be described as the physical quantities which are described by magnitude, and the proper unit are called the scalars. For example, the mass, length, time, density, energy, work, temperature, and charge. These are the few examples about the scalar quantities. In order to deal with the scalar quantities, we use the ordinary algebra rules. We can add, multiply, or subtract the scalar quantities with the help of ordinary algebra rules. On the other hand, the other quantity are the vector quantities, which can be described as the physical quantities which are completely described by magnitude with the proper unit and the direction are called vectors. Here the difference is about the direction. We need to attach the direction in order to completely understand the physical quantities. For example, the force, velocity, acceleration, momentum, torque, electric field intensity, and the magnetic field induction. These are the examples of vector quantities. And in order to add, multiply, or subtract the vector quantities, we used a special algebra, and that algebra is known as the vector algebra we will discuss in this chapter. We can express vectors by symbolically, as we use the bold face letter in order to express the vector quantities. Just like this, force F is bold and the velocity V symbol is bold, and same for that of acceleration. We can also express the vector quantities by using an arrowhead above the letter. Here you can see the vectors are represented by the letters with an arrowhead above it. We can also express vectors by graphical method. Here you see a diagram. We will choose the x-axis, y-axis, and the z-axis. Here you see I, j, and k are the unit vectors along the x, y, and z axis. We will discuss in the next section about the unit vectors. Here you see in this diagram the vector A is represented by the symbol A with an arrowhead above it, and the end of this vector you will see a unit vector A. Let us move to the concept about the unit vector. A unit vector is a vector having magnitude is equal to 1, or the unit magnitude is called the unit vector. Unit vector is used to describe the direction of a vector. We can express the vector A and its unit vector as the product of the magnitude of vector A with the unit vector will result the vector A. Or we can express it as a unit vector is described by the vector over and divided by its magnitude. A unit vector has a component along the x, y, and z axis. So here you can see that we can divide this vector A into its component like AX, AY, and AZ are its component along the x, y, and z direction. Here in the above diagram, I talk about the I, j, and k unit vectors that are along the x, y, and z axis. So we can attach them over here. Here in the next equation, you will see on the left hand side, there is a vector A, and on the right hand side, it is written in the form of its component. The first component is AX along the direction of x, and the I unit vector represents the x direction. Whereas the second component is AY, and here is the unit vector j representing its direction along the y-axis. And the third component is AZ. The unit vector here is k that represent the z direction. In space, the unit vector have the direction normal to the surface, and its magnitude of this vector can be expressed as, here you see that the magnitude of this vector A is expressed as A. On the right hand side, we will take the square root of these square of their components, ax square, ay square, and az square. Now we can add these vectors by using vector algebra. Here you see the process in which two or more vectors are added together to get a resultant vector is called the vector addition. Here in this diagram, we have two vectors. The first vector is along the x-axis, is represented by the vector A, and another vector you see over here, and its name is the vector B. We can use these two vectors to add them and get a resultant vector. Here, the first step is to place the tail of vector B on the head of vector A. In the next diagram, you will see over here that here is the vector A, and we place the tail of vector B along with the head of vector A, and now join the tail of vector A with the head of vector B. And this blue color vector represents the resultant of the sum of the two vectors. Mathematically, we can write it as, here you see its mathematical equation. Left hand side is the resultant vector, and on the right hand side we express it as vector A plus the vector B. So we can add them in the reverse order. We can choose vector B as a first vector. Here in this diagram, you will see that if we choose the vector B as a first vector, then we can attach the tail of vector A with the head of vector B. And now we can attach the tail of first vector with the head of the second vector. Here in this diagram, you will see the blue vector that represents the resultant vector. So we can say that the vector addition is commutative. We can say that A plus B is equal to vector B plus A. Here you will see that the important point is vector A plus B is equal to B plus A. This property is known as the commutative property. Vector addition is associative also. Here you see the mathematical equation. A plus B is associate with the vector C, and here is vector B plus C is associate with the vector A. So this is the mathematical equation. The result will remain the same. In this above diagram, you will see its expression. Here you will see that if we choose the vector A as a first vector and connect the vector B with this head, and this is the second vector, and if we add these two vectors A and B, in the center you will see the blue vector that represents the vector A plus B here. And if we want to add the third vector C with this resultant A plus B, so we can attach it over here. You will see that the C vector. And now if we add the resultant A plus B with this vector C, you will get another resultant right over here. You will see that is the sum of these three vectors A plus B, and then we add the third vector C over here. We can add them the other way around. Over here you see that if we choose vector B and C as a first vector, so here you see that if we choose vector A, vector B as a first vector, and then vector C as the second vector, and now we want to add the vector B and C, so will get a resultant B plus C over here. Now if we want to add a vector A or associate a vector A with this addition, so we can add it over here. You will see that this vector A chosen as a first vector, and the second vector is B plus C over here, and their resultant is the third vector over here. You will see is the sum of A plus B plus C. So the vector addition is associative in nature. And similarly, we will discuss about the vector subtraction. Vector subtraction is nothing else just like an addition. Here you will see the definition that the process in which two or more vectors are subtracted to get a resultant vector are called the vector subtraction. Here in this diagram, you will see another two vectors, vector A and vector B. And if we want to subtract these two vectors, we have to reverse the one vector. If we want to add the vector A and B by using head to tail rule, so we can see in this diagram over here, you will see that this is a vector A and there is a vector minus B opposite to the direction of this vector B. The magnitude will remain the same, but the direction is opposite to the vector B. And we choose a vector A as a first vector, and the minus B is chosen as the second vector. Here you see that we attach them with each other using a head to tail rule. And now connect the tail of first vector with the head of second vector. Here, this blue vector R represents the resultant of these two vectors. Mathematically, we can write it as on the left hand side, here you see the resultant vector, whereas on the right hand side, first vector is A, and here is the plus sign. Then we can write the second vector, that is minus B. And finally, we can write it as A minus B. Thank you for watching. Let us meet in the next lecture.